Hi guys, in this video we are going to discuss a question from forces. In our early videos we have already done many questions regarding A-level physics. If you haven't watched those videos, I have given the link in the description so you can go and watch them first. If you are new to this channel, don't forget to subscribe. Let's read the question. An object of mass 2 kg is attached to the hook of a spring balance and the latter is suspended vertically from the roof of a lift. What is the reading on the spring balance when the lift is first part ascending with an acceleration of 20 cm second minus 2, second part descending with an acceleration of 10 cm second minus 2, third part ascending with a uniform velocity of 15 cm second minus 1. Pause this video and try to do this question in your own. After that, watch the rest of the video. In this question, the main thing is you should draw a force diagram. Another main point is spring balance will give the reading by its tension. So this is the main point. Spring balance will give the reading as the spring's tension. So when we are calculating the reading, we should find the spring's tension. So we should draw the force diagram for the mass. After that, we can use the F is equals to ma equation and find the spring's tension. After that, we can directly tell the reading. So this is the simple steps. So first of all, you should know how to draw the force diagram for that object. So in this case, I'm going to do the part 1. So I'm going to draw. So in this question, I'm going to draw this mass 2 kg. Here is a spring balance, so I'm going to draw it also. And I have drawn that. Let's take this mass 2 kg. In this mass, there are two forces acting on this body. What are the two forces? First force is the weight. It's equals to 20 Newton. And the second force is which is acting on this body is tension. So I'm going to denote by T. So there are two forces. I have drawn that two forces. In the next case, we should find the acceleration of this body. We have given that the lift is ascending with an acceleration of 20 cm second minus 2. If lift accelerates with that value, the object inside the lift is going to accelerate in the same value. So that's the main point. So that object is also going to accelerate ascending with an acceleration of 20 cm second minus 2. Be careful, I am going to change this value into meter second minus 2. So if I change that, I am getting 0.2 meter second minus 2. So we have found the values of the acceleration. We have drawn the forces. Then we can directly use this in the equation. F is equals to ma. I am going to use that F is equals to ma for this object. If I am using upwards, the T is going to act upwards, so there is no problem with the sign. So T, weight is going to act downwards, so I should put minus, so minus 20. And the mass of the object is 2 kg into acceleration 0.2. If I simplify this, I will be getting 0.4, 20 plus 0.4, 20 plus 4 Newton. You should be careful. You should put the value with the unit. So you should be careful. The next thing, the second part, is descending with an acceleration of 10 centimeter second minus 2. In the same way, I am going to try for the second part. If you have understood this clear, you can try it in your own second and third parts. So in this way, I am going to draw that body, and I am going to mark the forces, only two forces, 20 and T, tension. The next thing, it's going to descending with an acceleration. So it's going to descending means it's going to come down. So 10 centimeters second minus 2, if I change to meter second minus 2, I'm getting 0.1 meter second minus 2. In this case, I'm going to use F is equals to ma downwards. Either you can use upwards or downwards, no problem, but it's easy to use downwards because the acceleration also in downwards. So if I use downwards, F is equals to ma for that object, resultant force downwards is equals to 20 minus T. So be careful when you are putting the values for F. And the mass is 2 kilograms and the acceleration is 0.1. If I simplify this, 0.2, so it's going to 19 plus 8 Newton. The latter part is the important part, ascending with a uniform velocity of 15 centimeters second minus 1. In this case, you can directly tell T is equals to 20 Newton. How can I tell like this? If there are no resultant force, the object will move in a uniform velocity or it will remain rest. It's the Newton's first law. So in this case, they are telling the lift is ascending with a uniform velocity. If that lift ascend with the uniform velocity, the object is also going to ascend with a uniform velocity. So in the object, we can directly tell there are no resultant force. If there are any resultant force, there should be an acceleration or deceleration. But in this question, they have told it's moving in a uniform velocity. So we can tell that there are no resultant force. In that object, there are only two forces, T and 20. That means weight. So both forces should be equal. So we can directly tell T is equals to 20 Newton. So the tension will be the readings in the spring balance. This is also a main point. I hope this video would be useful for you. So don't forget to subscribe our channel and don't forget to share this video with your friends. Thank you.